Okay, let's unpack this. Because today, I want to start our deep dive with a number. And not just any number. I'm talking about a number so staggeringly, incomprehensibly massive that it frankly breaks the human brain just trying to visualize it.
It really does. It's one of those numbers where once you actually understand the scale of it, you kind of just have to sit back and stare at the wall for a minute.
Yeah, exactly. So the number is 10 to the power of 200 to 1. Now, for anyone driving or doing dishes right now, let's just pause and appreciate what that actually means. That is a 1 followed by 200 zeros.
Right. And to put that into some kind of perspective, because our brains are terrible at exponential numbers, there are only about 10 to the power of 80 atoms in the entire observable universe.
Wow.
Every star, every planet, every speck of dust, only 10 to the 80.
So if you turned literally every atom in the universe into a lottery ticket, your odds of winning would still be practically 0 compared to this number.
Exactly. You'd need trillions of universes worth of atoms just to get started.
And yet, according to standard textbook science, the stuff you and I both learned in high school biology, those are the calculated odds against a functional biomolecule spontaneously assembling itself. We are talking about the very basic building block of life just happening.
Yeah, that's what biologists call the improbability paradox. Because if you assume the universe is just random, if you assume it's just chemicals bumping into each other in some warm little pond, the math literally says life shouldn't exist.
Right.
It is statistically indistinguishable from impossible.
Which leads to the standard narrative we've all heard, right? Life is a fluke. We're a biochemical accident, a miraculous mistake in a cold, dead, indifferent cosmos. We won a lottery that we had absolutely no business winning.
That is the standard view. The Riemannian view, to get technical, it assumes space is just a passive stage, a container where matter just dances around.
But, and here's where it gets really interesting and why we are doing this deep dive today, we have a stack of documents that completely flicks that script. Yeah. We're looking at the Panspatial Cosmology Briefing and the UCTE papers, and the thesis here is wild.
It's a total paradigm shift.
It really is. It basically says, stop worrying about the odds. Because the odds are wrong.
Right, because the fundamental assumption about the container itself is wrong.
Exactly. The argument these sources are making is that the probability of life isn't low. It's inevitable. That life isn't a chemical accident, but a deterministic result of the actual geometry of space itself. So, what if space isn't empty, but alive?
It's a profound shift. We are moving from a biochemical-centric view, where life is defined by the squishy matter it's made of, to an ontological-centric view, where life is fundamentally geometry. The matter just fills in the lines later.
So before we have a single atom, before we have carbon or water or sunlight, we already have a blueprint.
Precisely. The geometry creates the slot, and matter falls into it.
Okay, I'm skeptical but totally intrigued. Because space is alive sounds a bit like we're about to start burning sage and talking about vibrations. But these sources are heavy on the math and physics. So let's set the stage here. The sources keep using this specific term, FCHP space.
Finsler fractal coherence, hyperphase space.
Which sounds like a government agency from a sci-fi movie, but we really need to break this down because the whole theory rests on this. What is the fundamental difference between the space we think we live in and this FCHP space?
So the space you learned about in school, the space of Einstein's general relativity, is Riemannian. Imagine a bedsheet.
Okay, a bedsheet.
You pull it tight,
yep.
It's smooth. If you put a bowling ball on it, it curves, and that's gravity. But inherently, it's smooth. It has no texture. It has no grain.
It's vanilla. It's just there.
It's very vanilla. It has zero torsion, meaning it doesn't twist. It has no inherent handedness or chirality. It doesn't know left from right. And critically, boundaries like the edge of a soap bubble are treated as mathematical oddities. In Riemannian space, a vacuum is a totally dead vacuum. Nothing happens there unless you put matter in it.
And that's why we have the 10 to the 200 problem. In a dead vacuum, if you want a DNA helix, you have to wait for atoms to bump into each other trillions of times until they accidentally stick in a spiral.
Exactly. You are basically trying to build a Ferrari by shaking a box of car parts.
But FCHP space is different.
Radically different. FCHP space is an active, generative medium. It's not smooth. It's textured. Think of it less like a bedsheet and more like a flowing river.
Okay, a river. I can picture that.
A river has currents. It has eddies. It has whirlpools. Those structures exist in the water even if there are no boats or sticks floating in it.
So the vacuum itself is moving or flowing.
It has torsion, which means the space itself has a built-in twisting flow. It has chirality, meaning it has a default handedness. It prefers flowing left rather than right. And it's hyperfractal.
Hyperfractal. Let's pause on that one. We know fractals like the Mandelbrot set or fern leaf.
Right, self-similarity. The small part looks exactly like the big part. In SCHP space, this means the texture of space repeats at every single scale. Whether you are looking at a galaxy or an atom, the geometric rules are exactly the same.
So going back to the river analogy, if space is XCHP, it's not a passive stage. It's a river with whirlpools that are already there, just waiting for something to fall in.
That's the key. If you throw a stick into a river with a whirlpool, the stick will spin. It doesn't spin because the stick decided to. It doesn't spin because of a random accident. It spins because the geometry of the water forced it to.
And in this analogy, the stick is matter, and the whirlpool is life.
Exactly. The improbability of life only exists if you assume the river is a stagnant pond. If space is SCHP, the odds totally dissolve. Life is just what coherence does when it flows through these geometric structures.
This is a massive claim. We're essentially saying the universe is rigged.
Rigged is the perfect word for it. It's biased toward complexity.
But I want to push back a little here. Torsion and flow in a vacuum. It's hard to wrap your head around. Space is empty. How does empty space twist? Are we talking about a physical force?
We are. In standard physics, we usually ignore torsion because it's very weak at large scales. But in this model, torsion is a fundamental property of the manifold. Imagine wringing out a wet towel. You are applying a twist to the fabric itself. FCHP says the fabric of the universe is constantly being wrung out. It's spiraling.
So there is a tension in the nothingness.
Yes, a geometric tension. And that tension acts as a mold.
Okay, so let's get into the mechanics of this mold. The sources list these things called pan-spatial geometric operators, which sounds very technical, but they seem to be the tools space uses to build life.
Right. Think of these as the bridge between the invisible geometry and the squishy biology we see in the microscope.
Let's run through them. First up, and we've touched on it, torsion, but specifically, how does twist in space become biology?
In pure geometry, torsion is just a vortex in the coherence flow. But when you introduce matter, that torsion translates directly into structure. It becomes DNA helicity.
The double helix.
The double helix. Have you ever wondered why DNA spirals? Why not a ladder? Why not a grid?
I just assumed it was chemically stable.
That's the chemical answer.
Mm-hmm.
But the SCHP answer is that the DNA molecule is filling a mold. The space where the molecule formed was twisting, so the molecule had to twist. It becomes protein folding. It becomes the spiral growth of a seashell, or the way a vine climbs a tree.
So the snail doesn't know it's making a spiral shell, it's just building in a straight line through curved space.
In a sense, yes. It's following the path of least resistance, and in a torsion-based universe, that path is a spiral.
Okay, that makes perfect sense. Next one is coherence gradients.
A gradient is just a slope, a difference in energy or flow. Think of a hill. Water naturally flows down the hill. In FCHP space, these gradients define zones of identity. In biology, this becomes the cell membrane.
The skin of the cell.
Right. A membrane is really just a physical barrier maintaining a gradient, keeping the stuff inside distinct from the stuff outside. In this theory, the gradient exists in space first. There is an energy cliff. Matter piles up against that cliff and forms a wall.
So the cell wall is just a solidified energy cliff. That's a really cool image.
It reverses the causality entirely. We usually think the cell builds the wall to hold itself together. This says the wall was a geometric boundary and the cell just filled it in.
Next is hyperfractal iteration. We mentioned the nesting doll idea earlier.
Right. This is the copy, paste, shrink command of the universe. In biology, this is everywhere. Look at your lungs. The trachea branches into two bronchies. Those branch into bronchioles. Those branch again and again, getting smaller but keeping the exact same shape. That is a fractal. Look at a tree. The branch looks like the whole tree. The vein of a leaf looks like the branch.
And standard science says this is just efficient packing.
It is efficient. But why is it efficient? FCHP says it's because the space itself is fractal. The biology is just tracing the recursive layering of the coherence field. It's a direct download of the geometric code.
It's like pouring plaster into a mold that has infinite detail.
Exactly.
Okay, this next one sounds the most complex. Laminar turbulent phase transitions.
It sounds scary, but you see it every day. Light a candle and blow it out. Watch the smoke.
It goes up in a smooth, straight line for a bit.
That's laminar flow. Smooth, organized. Then suddenly it breaks. It starts swirling, chaotic, messy. That's turbulence.
Okay, I see it.
That transition point, the edge between smooth and chaotic, is where the magic happens. That is where complex systems thrive. In biology, these phase transitions power neural oscillations.
Brainwaves.
Brainwaves. Your brain is constantly surfing the edge between order and chaos. If it's too ordered, you have a seizure. If it's too chaotic, you're insane. You need that transition zone. FCHP says this rhythm is driven by the fluid dynamics of space itself.
So our thoughts are basically surfing geometric turbulence.
In a way, yeah. And it drives metabolic cycles too. The rhythm of your heart, the cycle of ATP production in your cells. These are turbulent bursts in the coherence field.
And finally, we have multi-shell boundary hierarchies.
This is the layering of identity. You have a cell. A group of cells makes a tissue. Tissues make an organ. Organs make an organism. Organisms make an ecosystem.
It's the nesting dolls again.
It is. But FCHP says this isn't accidental. Space naturally organizes itself into shells or layers of coherence. Biology just occupies those shells.
So we're looking at a universe where the hardware for life, the spirals, the walls, the branches, the layers, is pre-installed in the operating system.
And chemistry is just the software running on that hardware.
Which actually brings us to the code itself. The sources talk about the biogenesis equation. And I love this because usually when people talk about life as geometry, they wave their hands and say vibes. But here we have actual math, an inequality.
We do. And it's quite elegant. It basically defines the exact moment a thing becomes a living thing.
The equation is sigma times chi times script f times delta c is greater than gamma critical. Now I want to walk through this variable by variable like a recipe. If you want to cook up some life, what do you need? First, sigma.
Sigma represents torsion magnitude. You need a twist. How strong is the vortex in that region of space? Is it a stagnant pool or is it a raging whirlpool? Without the twist, you simply can't build the spiral structures needed for information storage like DNA.
Okay, so you need a cup of twist. Next, chi.
Chi is chirality flux, the handedness. You need a bias. You can't have a 50-50 mix of left and right or structures won't stack properly. You need a strong left or right current.
Got it. A tablespoon of bias, then the script F.
That's hyperfractal depth. This is complexity. How many layers deep does the recursion go? If space is smooth, F is 0. You need space that is crinkled, layered, folded over itself. That provides the massive surface area for complexity.
And then delta C.
Coherence gradient. This is the battery. This is the food. A gradient is a difference in potential. Life needs to eat energy to survive entropy. This variable represents the steepness of the energy hill available to harvest.
So you have twist, bias, complexity, and food. And all of that multiplied together has to be greater than gamma critical.
Which is the critical curvature threshold. Think of this as the resistance of the environment. The universe naturally wants to decay into disorder. That's the resistance. If your product of twist, bias, fractal depth, and energy is strong enough to punch through that resistance, snap, a boundary forms. A self-maintaining system pops into existence. It creates an inside and an outside.
It's not optional.
That's the key to the whole theory. If the inequality is met, life must emerge. It is totally deterministic.
So if you have these conditions in a beaker or on a planet or in a gas cloud, life happens.
Carve?
That brings me to the part of the source material that really bent my brain, the concept of proto-life without chemistry.
Yes. This is where we leave the biology textbook behind entirely.
Because I'm used to thinking of life as stuff. Slime, bugs, people, carbon, hydrogen, oxygen. But you're saying that even in a complete vacuum, a hard vacuum with 0 atoms, you can have something that acts like life.
According to panspatial cosmology, yes.
Yeah.
You can have proto-metabolism.
How do you have metabolism in a vacuum? What are you eating? You can't eat a sandwich if you don't have a mouth, or a sandwich, or atoms.
You're eating coherence. The source describes coherence dips. Imagine regions in the fabric of space where the density of coherence drops, forming a basin.
Like a sinkhole in the river.
Exactly, a sinkhole. Now, physics dictates that nature abhors a gradient. High pressure wants to go to low pressure. So coherence from the surrounding space naturally flows into that sinkhole.
It rushes in.
That flow, that is a gradient. The basin pulls coherence downhill. That is the geometric equivalent of eating. It is harvesting energy flow to maintain its shape against the surrounding pressure.
So it's a ghost cell, a structure made of nothing but twisted space, sucking in energy to keep itself stable.
And it doesn't just eat, it replicates.
Geometric mitosis. This part sounded impossible. How does a hole in space have babies?
It comes back to torsion. The papers describe torsional shear instabilities. Imagine this coherence bubble is spinning, because of the torsion. As it harvests energy, it grows, it elongates.
Like a water balloon stretching out.
Right. And as it spins faster, the middle gets pinched. The shear force becomes too great for a single boundary to hold.
So it wastes in the middle and snaps.
It bifurcates. The boundary deforms and splits. One boundary becomes two stable vortices.
And it didn't need DNA to do that. It didn't need a nucleus.
No DNA. The fact that the two new bubbles look just like the first one is enforced by the boundary equations of the space itself. It's reproduction driven by pure geometry.
So billions of years before the first chemical cell appeared on Earth, space might have been filled with these reproducing ghost bubbles.
That's the theory. And eventually, matter got trapped in those bubbles. The ghost put on a suit of armor. And that armor is what we call biology.
I need to see this. The outline mentions simulation data because I can hear the listeners saying, cool story, but prove it. Did they actually model this?
They did. They ran numbers on the nonlinear FCHP equations. This isn't just philosophy, it's computational physics.
They did 2D and 3D simulations. What did the screen show?
In the 2D simulations, they found these specific gradient harvesting basins appearing spontaneously. They actually put a number on it, a minimum coherence value of negative 0.0008679.
That's incredibly specific.
It is. It represents a stable dip, a pocket where the geometry locked in and refused to dissolve.
And in 3D?
In 3D, it gets haunting. The field evolves into a spheroid-like minimum with intensifying layers.
Describe that.
Imagine a computer screen showing a vector field. At first, it's just random noise. Then a swirl forms. It tightens. It forms a perfect sphere. And inside that sphere, layers of flow start moving in opposite directions, maintaining the boundary.
That looks like a cell.
It looks exactly like a cell, or a virus, or a planet. They call them vortex attractors, structures made of pure coherence that look and act like biological membranes.
And just to be crystal clear, in this simulation, there is absolutely no matter.
No atoms,
Yeah.
no chemistry, just the math of space acting on itself.
That is, well, it's compelling. It suggests that the shape of a cell isn't something evolution invented. It's something the universe imposed.
Evolution just optimized it. The shape was waiting there all along.
Okay, I want to pivot to one of the biggest smoking guns in this theory. Because abstract bubbles are one thing, but we have real-world mysteries that standard biology just can't explain. Let's talk about chirality.
Ah, yes, the left-handed problem. This is one that keeps biochemists awake at night.
For those who don't know, break down the mystery. What is the handedness problem?
So, biological molecules like amino acids, which build proteins, have a shape. They're 3D structures, and they can be mirror images of each other. We call them left-handed or right-handed.
Like gloves. A left glove fits your left hand, but not your right.
Exactly. Now, chemically, in a test tube, a left-handed amino acid acts exactly the same as a right-handed one. They have the same melting point, same reactivity. If you make amino acids in a lab from scratch, you get a 50-50 mix. It's a coin flip.
Okay, so nature should be 50-50.
Logic suggests that. But in nature, on Earth, every single amino acid in your body, in a tree, in a bacteria, in a mushroom, is left-handed.
All of them.
All of them. And all the DNA and sugars are right-handed.
That seems really unlikely.
It's statistically impossible. It's random. It's like flipping a coin a trillion times and getting heads every single time.
So what is the standard scientific explanation?
The standard view is it was a frozen accident. Basically, early on, maybe by pure chance, the first life just happened to be left-handed. It ate all the food, reproduced, and crowded out the right-handed potential. It's the winner-take-all hypothesis.
So if we went to another planet, standard biology says we might find right-handed life.
Exactly. If it's a coin flip, another planet could land tails.
But the panspatial cosmology sources say wrong.
They say absolutely not. The expert view here is life cannot be acral, and the universe chooses the hand.
Because of the torsion.
Because of the torsion. Remember, FCHP space twists. It generates what's called a chirality pseudovector. Space itself has a twist. It inherently prefers one side.
So the coin isn't a fair coin.
The coin is weighted heavily. The source calls it the chirality cascade. The torsional vortices in space naturally favor the left-handed geometry for amino acids. It's like a screw. You can only turn a screw one way to tighten it.
So space acts like a screw thread?
Yes. And then that bias is amplified by golden mean scaling, that hyperfractal recursion we talked about. A small bias at the quantum level becomes a total mandate at the biological level.
So space twists left, so the first proto-life twisted left, and everything built on top of it had to be left.
Precisely.
This leads to a massive prediction, the universal conclusion.
This is the first big test. If we find aliens, if we find bacteria on Mars, if we find slime on Enceladus, they will use L-amino acids.
It is a cosmic requirement.
Not a planetary accident.
Right.
If we find right-handed life anywhere, this whole theory goes in the trash. It's falsified. But if we find that life everywhere is left-handed, that is huge evidence that the vacuum dictates the biology.
It's amazing to think that the shape of the DNA in your cells might be dictated by the twist of the vacuum of space itself. It connects the very small to the very large in a way few theories do.
It means we aren't isolated accidents. We are aligned with the grain of the cosmos.
Speaking of connecting things, let's move to section 4, biologistics. This is where we apply this high-concept geometry to the actual squishy biology we know.
The materialified geometry section.
I love that phrase. Biology is just geometry wearing a suit of matter. But let's get specific. How does this affect, say, my brain?
Let's talk about neural signaling. We usually think of thoughts as purely chemistry. Neuron A fires a neurotransmitter packet to neuron B. It's a chemical handshake.
Right, serotonin, dopamine.
But FCHP suggests that synaptic plasticity, the ability of the brain to learn and rewire itself, is actually a result of torsional strain in the coherence boundaries.
Explain that.
Think of a thought not as a chemical drip, but as a geometric knot being untied. When you learn something, that aha moment, the theory suggests the coherence boundary between neurons is realigning. It's optimizing the flow to reduce drag.
So a blockage in thinking might be a literal geometric blockage.
A region of high torsion or turbulence, learning is smoothing out the flow.
What about metabolic cycles, the energy that keeps us alive?
This connects back to those laminar turbulent transitions. The source mentions Reynolds number analogs.
Whoa, break check. Reynolds number is fluid dynamics. It tells you if water is flowing smooth or splashing around.
Right. In fluids, the Reynolds number tells you if flow is smooth or chaotic. The theory suggests that metabolic cycles, like the Krebs cycle that powers your cells, are actually triggered by turbulent bursts in the coherence field.
So your cells are harvesting energy from little geometric storms.
Yes. Life exists on the edge of chaos. If the flow was perfectly smooth, you'd have no energy gradient to harvest. You'd starve. You need the turbulence to extract the power. Your mitochondria are basically tiny turbines in a coherent stream.
And then there's evolution.
Evolutionary adaptation. In the Darwinian view, evolution is random mutation plus natural selection. It's blind.
But in FCHP?
It's recursive boundary optimization. The organism is trying to find the perfect geometric fit for its environment. It's not blind. It's guided by the gradients.
And here is where it gets really interesting for sci-fi fans. The theory predicts that evolution should occur faster in regions of high torsion.
Yes. High torsion means more twist, more energy, more complexity in the vacuum.
Where would we find high torsion?
Near galactic cores. Or along the massive filaments that connect galaxies. The highways of the universe.
So if you live near the supermassive black hole at the center of the galaxy,
evolution might be on fast forward. The geometry there is driving change much harder than it is out here in the quiet suburbs of the spiral arms.
that implies the center of the galaxy could be teeming with hyper-advanced life while we're just the slow-moving country bumpkins out here on the rim.
It's a distinct possibility. The core is the city. We live in the sticks.
I want to get a little technical for a minute. The outline mentions Finsler and Randers metrics.
The deep dive technicality.
Yes. We've been saying FCHP in geometry, but what is the actual math under the hood? I saw Randers metrics and my eyes glazed over. Save me.
It's actually a really cool concept once you strip the jargon away.
Yeah.
Randers metrics are a way to measure distance, but they allow for asymmetric distances.
Asymmetric distance, meaning the distance from A to B is not the same as the distance from B to A.
Exactly.
That breaks my brain. If I walk to the store and walk back, it's the same distance. The sidewalk didn't get longer.
In Ragmanian space, dead space, yes. But think about walking into a strong wind.
Okay. I'm walking to the store and the wind is at my back.
It's easy. You're being pushed. It takes 10 minutes and almost no energy. Now turn around and walk home against the wind.
It takes 20 minutes, I'm exhausted, and it feels like a mile longer.
Exactly. The effective distance is different because of the medium you are moving through.
Because of the flow of the air.
Right. Now imagine space itself has a wind, a coherence current. That is the torsion.
So space has a wind direction.
The Randers metric mathematically describes a space where there is a built-in flow. And this asymmetry is what creates the coherence currents that drive life. Light is the act of sailing downwind.
And death is trying to swim upstream.
In a way, yes. Entropy is the resistance. Life is finding the path of least resistance through the Randers metric. When you align with the flow, you thrive. When you fight it, you dissipate.
That feels profoundly philosophically satisfying.
It really is.
Which brings us to the biggest picture of all. Section 5. Cosmic implications.
Astrobiology 2.0.
Traditional astrobiology says follow the water. We look for Goldilocks zones. Not too hot, not too cold, liquid water.
Panspatial astrobiology says follow the torsion.
If this theory is right, we have been looking in all the wrong places. Or at least, we've been way too narrow.
We've been looking for wet life, biology like us. But FCHP suggests life creates its own stability boundaries. It implies life could exist in environments we consider instantly lethal.
Give me some examples. Where should we look?
Molecular clouds. Huge clouds of cold gas in deep space. They have high coherence gradients and massive surface area.
Stellar interiors. Inside stars.
This is a favorite of mine. If life is a geometric vortex harvesting energy, a star is a buffet. The torsion and energy gradients inside a star are massive. You could have magnetic flux life forms living inside the plasma,
Quasar hypercores.
the most energetic environments in the universe. If torsion drives evolution, quasars might be the fastest evolutionary engines in existence.
And vacuum phase transitions. Life in the void itself.
If the torsion is strong enough, you don't need matter, you just need the geometry. You could have pure coherence life forms floating in deep space.
This dramatically expands the search radius. It implies the universe is teeming with life, just not necessarily meat life like us.
Exactly.
And this touches on relativity and dark energy.
This is a major point in the source material. It claims that general relativity, Einstein's masterpiece, is just a reduced mode of FCHP. It's what you get when you ignore the torsion.
And dark energy, that mysterious force pushing the universe apart.
Solved. In this model, dark energy isn't a mysterious fluid. It is derived as torsional stress within the Finsler-Randers metric.
It's the twist unwinding.
Think of a spring. If you twist space, it wants to expand. That push is what we call dark energy. It solves the problem without needing fine-tuning. It's just how the geometry works.
Which brings us to the big question, the Fermi paradox.
Where is everybody?
If life is inevitable, if it's geometric, if it's everywhere, why haven't we heard from them? Why isn't my radio picking up alien jazz?
The panspatial resolution is fascinating. It agrees that life is ubiquitous. It's the generic state of space.
So they are out there.
They are everywhere. But the theory suggests that advanced civilizations may integrate into non-material boundary states.
Interpret that for me, because that sounds like they went to heaven.
Think about efficiency. Matter is heavy. It breaks. It requires massive energy to move. If you are a sufficiently advanced civilization, why stay in a meat body? Why stay in a metal spaceship?
So where do you go?
You become the geometry. You integrate your consciousness into the coherence field itself. You become a vortex attractor on a massive scale.
They uploaded themselves to the vacuum.
In a sense, they became pure coherent structures. They don't need spaceships. They reside in the curvature of space.
And because our sensors are Riemannian biased, because we are looking for matter, for heat, for radio, we can't see them.
We're looking for smoke signals, and they are communicating via the structure of space-time. We are literally blind to their existence because our definition of existence is too narrow.
That gives me chills. It suggests we are walking through a crowded room, but we're wearing a blindfold.
We might be looking at a nebula and just seeing gas, while it's actually a thriving city of coherence-based entities.
So if we pull all of this together, Section 6, the living universe.
The synthesis.
It sounds like the universe itself is an organism.
The expert view confirms this. If you look at the criteria for a living system, does it maintain a boundary?
Yes, the cosmological horizon.
Does it have gradient flow?
Yes.
Does it have identity?
Yes, coherence density.
So the universe satisfies the definitions of a biological entity. And this brings in the concept of scale invariance.
Meaning life looks the same at all sizes.
A proton is minimally alive. It has a boundary. It maintains its identity. A cell is mid-scale life, and a galaxy.
A galaxy is macroscale life.
The source says every galaxy is an organ.
So the Milky Way is like a liver or a heart in the body of the universe.
And we are just tiny molecular machines working inside that organ.
This leads to the final ontological conclusion, and this is the one to write down.
Life does not emerge in space. Life emerges as space.
Say that again, that's the bumper sticker?
Life emerges as space. Matter is just the solidified mode of space's living architecture. We are inhabitants of the universe. We are the universe materialized. We are the foam on the top of the wave.
That is heavy. And beautiful. It means we belong here. We are an inevitable result of the cosmos being what it is.
It removes the loneliness. We aren't accidents. We are inevitable.
Okay, before we float away into pure philosophy, we need to ground this. We need to talk about falsifiability.
Right, because if you can't prove it wrong, it's not science, it's religion.
How do we prove we aren't just making up cool stories? The source gives us a kill switch. Criteria that would disprove the theory immediately.
Right. Here are the 3 ways to kill panspatial cosmology.
Number 1.
Chirality. We talked about this. If we find extraterrestrial life on Mars, anywhere, and it is acral or opposite-handed,
The theory is dead.
dead on arrival. The theory says the twist of space forces amino acids everywhere. One right-handed Martian microbe destroys the entire mathematical framework.
That's a high-stakes bet.
It is, but it's a definitive one.
Number 2.
Gravitational waves. We have detectors like LIGO now. They measure ripples in space-time from colliding black holes. If FCHP is real, those ripples should have a specific twist signature, a polarization that standard general relativity doesn't predict.
So if we look closely at the waves and they are smooth, without that twist.
Theory dead.
Number 3.
Fractals. The theory predicts the universe should look fractal clumpy in a self-similar way, up to huge scales, like 600 million light years.
And if we map the galaxies and they are smooth and uniform,
Then the hyperfractal concept is wrong.
so we have a roadmap. We can actually test this.
And we were testing it. The James Webb Telescope, the dark energy surveys, the next-gen gravity detectors, they are all gathering the data right now that will either prove this right or bury it.
This has been an incredible journey. From 10 to the 200 to 1 to a universe that is alive, breathing, and twisting us into existence.
It certainly changes how you look at the night sky. You don't just see empty dark, you see a living ocean.
It really does. But here is a final thought to mull over, something to take with you after we wrap up today. If life emerges as space and advanced civilizations integrate into that geometry, what happens when humanity finally maps the full FCHP structure of our local space? Will we just observe it, or will we figure out how to engineer the vacuum itself to build new branches of the cosmic tree? Maybe that's the real next step in evolution.
That is quite the thought to end on.
Thanks for exploring this with us. The universe is recognizing itself through you. See you next time on The Deep Dive.